Alright, hello everyone. So today I will be starting with the concept of fields, and the first few videos will be a bunch of definitions only. It's only in the later videos that we'll actually start deriving some results. But these definitions, the first of them being that of fields, will actually help us in the later videos. Okay, let's begin. So a field is a collection of objects, and that collection of objects I'll denote it by this blackboard bold F. And along with this collection of objects F, we have the addition operation and the multiplication operation defined as well, and these operations adhere to a few rules. So in short, a field is any triplet looking like this with a collection of objects F and an associated two operations of addition and multiplication, and these follow these six rules. So the first of the rules is closure. So if x and y are two elements of F, then x plus y and x times y will also be an element of F. Okay, the next is commutativity. In commutativity, the order of the operands don't matter. So x plus y is the same as y plus x, and similarly x times y is the same as y times x. Next comes associativity. So in associativity, if x, y, z are elements of F, then if you have to do a sum of three elements, then x plus y plus z is the same no matter how you evaluate it. If you do y plus z first and then add it to x, or if you do x plus y first and then add it to z. And multiplication, it also works in the similar way. X times y times z is the same no matter how you do it. If you do y times z first and then multiply it to x, or if you do x times y first and then multiply it to z, the result will be the same. And now we come to a few of the crucial elements that define a field. The first of them being identity. So both these operations come with an identity element. So in the set F, there will exist a 0 such that x added, any x added to 0 will give the same element x. And similarly, there is also a 1 that is in the set F, and that's the multiplicative identity, because when you multiply 1 with any other element, it returns the same element again. And next is the concept of an inverse. So I have defined the concept of identity, which is basically special elements that the first of which, when added to any other element of the field, will give it itself, and similarly the second one, when multiplied with any element, will give the same thing again. And now associated with that is the concept of inverse, which is that if there exists for any x in F, there will always exist a minus x. So the minus x is what we used to denote the additive inverse, and x plus minus x will give you 0. That is the additive identity. And similarly, for any x that is not 0, there will exist a x inverse, so x raised to minus 1, which is the multiplicative inverse, such that if you multiply this x raised to minus 1 with x, then you will get the multiplicative identity, that is 1. And finally, we have the distributive property, which states that x times y plus z is the same as x times y plus y times z. So these six things are what you have to memorize, and these are rules that, well, these are the rules of the game, so you need to know them. There is exactly no logic behind them that I can explain, but this is what by definition a field is. A field is any triplet that is a set F, a collection of objects, and two operations, addition and multiplication, which follow these rules. And these rules are what you have to memorize. And with that, I finish my lecture on fields. The next one, we'll be looking at a few properties of fields, and I'll see you next time for that. Stay tuned.